Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Before we jump into topics, a quick mention that we will be going on winter break after our Bounty and Binary episodes next week. That's on the 13th and 14th. Just make sure that I'm correct on that. Yep, that is next week. And then we'll be returning on January 10th and 11th. So just a quick heads up for that. So let's jump into some of our topics for this week. Up first, we have a Humble Bundle. So last week on our binary episode, we covered the Humble Bundle for hacking that came out. But we didn't mention that on the Bounty episode last week. So before exploit topics today, we wanted to mention that for those who might not have caught the binary episode. And Z did a review on it and talked about some of the books. We won't go into as much detail here or as much of a review here. If you want to check that out, you can check out our VOD from last week. But there's still a few books that I know you wanted to call out, Z, so I'll let you go ahead.
Yeah, because during the binary episode, I tried to talk more about the binary ones. I ended up talking a lot more than I planned about several of the books, but I'll try and keep it brief this time, and you could reference last episode. Um, you're doing the bounty hunting. Serious Cryptography is basically my favorite book to recommend when it comes to crypto issues. For like security professionals, it does get a little bit into the math. Like it's not averse to touching on the math at all, but it kind of gives you a more straightforward, like every section has a what can go wrong. So like when you're looking at crypto, it helps you understand what the actual issues are. It's the type of book I wish I had when I was kind of learning on the crypto side. Real world bug hunting, I actually reviewed that on a podcast episode at some point. Uh, Not a book I'd go out of my way for, but it has some real world bug reports. It's essentially a collection of bug reports and bug bounty reports from the past. It has a bit on teaching the issues, not the greatest on that front. Like Portsmouth Academy is free and available for that, but I mean, it's a reference. You get it in this bundle anyhow. If you're thinking about a career on like ethical hacking or any like just within the offensive side of the security industry, this ethical hacking hands-on introduction to breaking in is a fairly recent book. I think it's like from September. And it covers a lot more than I thought. And well, none of the topics I'd actually recommend is like, go here to learn vulnerability research. What I appreciate about that book is the fact that it does cover several different realms of hacking, because often when you hear ethical hacking, you probably immediately think, or at least I do, of network penetration testing. And that is just one area of it. Like I do application security, which, or at least that's largely been my focus, which it also talks about in this book. It just gives a nice overview of several areas, and it is relatively modern and recent content. Thank you, Imperial G, for the 4 month sub. Uh, yeah, coming back on their Black Hat Python. I mean, if you don't know Python already, give it a shot and just learn it. It'll help you out. And that one's updated for Python version 3. The original Black Hat Python was V2. So
Yeah, I
I
think the
guess
physical copy I have is V2. So
kind of the rundown on them. I mean, it's a good bundle. Several of these books are fairly recent. I think over half of them are from within the last like 3 years, and those that are dated, it's really Practical Malware Analysis and The Tangled Web, which are the oldest two books, 2011 and 2014 respectively. And even there, like there are things you can learn out of them, but you've got so many other books also that you can kind of learn out of. It's a good bundle, just on a whole. And I mean, you can send money off to like the charities this time. Includes Let's Encrypt
yeah,
and No Starch Foundation.
yeah. Overall, a just a great bundle where there's some good books in there for sure. Like I said, like kind of hinted at earlier, there's a few books in here that I have a hard copy of. So they're definitely useful.
And taking a question out of chat from Hidden. As a DevOps engineer, I want to do some basic security checks against our web app. Any simple ideas what I can do? You want to do some basic stuff? I mean, look at something like SemGrep. You can just write some fairly simple rules that can run automatically as part of like the CI/CD pipeline. There's tons of rules already written, but you could write some specific to your application, just patterns that you see developers actively doing. It's one of the easiest ways to get some quick wins, and that way the security people can actually focus on, um, frankly, like better, more interesting issues instead of the low-hanging fruit. So yeah, some like semgrep, CodeQL if you're open source, or if you have GitHub Enterprise. And just learning about the web stuff if you're not familiar. Portswigger Academy is a good place for that.
All right. So with that said, we'll get into some of our exploit topics for this week. First, for exploits, we have a blog post at Lightspin on a cross-account Jupyter notebook instance takeover on AWS SageMaker, which is Amazon's machine learning service offered through AWS. It all started off with a self-XSS through Notebooks Lab's endpoint, where it was possible to change the content of what's running on the lab endpoint and achieve XSS. Now, this isn't super useful or interesting right away because, I mean, it is self-XSS. You control the content of that page because you own that instance. It's nothing like groundbreaking there. But it gets interesting when you consider the fact that all Jupyter Labs notebooks in SageMaker go under the same domain, under the subdomain of sagemaker.aws. So cookies start to get interesting there because cookies, like if you can set up a cookie using the XSS that goes to like the sagemaker.aws subdomain as a whole, you can end up controlling cookies that go to other Jupyter Labs notebook instances. So that's basically what the attack is here. One of the cookies under the SageMaker subdomain is this XSRF cookie, which is used for the full domain and is like a CSRF token, as I understand it. And cookies are specific to the domain, meaning you can have cookies of the same name so long as they're for different domains. So what happens if you use the XSS to create that XSRF cookie that applies to the entirety of the sagemaker.aws subdomain? Well, that cookie ends up getting forwarded to all subdomains that are visited, including the victim's own instance on their own AWS account if they visit it. So that leads to a CSRF, which can then be used to open a terminal to the victim's Jupyter Lab instance, and a cross-origin WebSocket can then be used because the origin header isn't checked or anything. And yeah, the researcher then took it further, creating a Jupyter Lab extension and using the CSRF to install the malicious extension on the victim's Jupyter Lab instance. Yeah, I mean, fairly straightforward attack, but it is basically going after the way that the cookies are used here. They point out that like same site, you would think that same site would be an issue here, since most browsers like Chrome, the default cookie same site attribute will be set to lax, meaning the cookie shouldn't be sent on normal cross-site requests, but only when navigating to the origin site at like the top level domain level. Um, but the researcher found this weird thing where Chrome will kind of ignore like that stipulation if a cookie is set without the same site attribute within a 2-minute grace period. So if it's been within 2 minutes since you've set a cookie that wasn't set with an explicit same site attribute, it will still allow that cookie through on cross-site requests, even though it should be defaulting to lax. That is set to be removed in the future. It seems to be like a legacy support kind of thing. I think they call it like post plus lax or something like that. But yeah, for the moment, it's still there, and it was fully taken advantage of here. This was a cool trick that I wasn't aware of at all. I don't remember like any topic we covered before covering this trick, so that was like the coolest thing in the article for me for sure.
Yeah, I definitely didn't know about Chrome doing that, or it's one of those things I feel like I maybe read somewhere and then just forgot about. Which I guess so often, hacking involves. That said, reading this, I also thought, or actually, I was reminded on Discord in a completely different context about another sort of attack that I think might be relevant here. And I'd be interested if anybody knows for sure. But there was an attack, cookie jar overflows, which you could use to get around HTTP only cookies. And what you would do is effectively, browser has a limit on browser can only hold like X hundreds of cookies per per site. So what you would do if you had like this sort of self-XSS or some sort of XSS really is you could create, hundreds and hundreds of cookies, and the browser will drop the oldest cookies first. And then that will include dropping HTTP only cookies, which then lets you reset the value of the cookie with something new that isn't HTTP only. Um, and that will just give you the ability to set the cookie. So what I think may have worked here, and I didn't confirm it. I meant to do that during the weekend, but I've had some other fun issues coming up for myself. But what I think you might have been able to do here also for an attack would be to do that cookie jar overflow, get rid of the XSRF cookie itself, and then replace it with your own known value that you can then use here. That way you wouldn't have to deal with the same site aspect of it. That said, you're also clobbering a bunch of cookies when you do that, unless you can get lucky and it's like the first cookie removed, but you also don't necessarily know how many cookies it can store. Different browsers do treat that differently. So you generally end up clobbering a lot, which can make it more difficult. But it's an option here for dealing with the same site aspect once the Chrome thing no longer works. Or at least I believe it would be. Like I said, I haven't tested it specifically with same site cookies. It is something I've seen used with HTTP only.
Yeah, that's a cool attack, and again, I don't remember hearing about that one or seeing anything about it. So yeah,
I think
that's
it's in
that's a cool
like
mention.
Browser Hacker's Handbook, I think might be where I first saw it.
Oh, okay. But yeah, I mean, overall, like I was saying, like it's not a super complex issue, but it's just based on the fact that, um, you know, if you have code running on a domain that could host other interesting things, and you can set the cookies, then there's some dangerous stuff that can happen here. I when it comes to like trying to pin down who you would put the issue on here, it's a little bit interesting because like this is an intended feature, right? To be able to run code on that website. And I could imagine them thinking like the same site stuff could protect them. Um, so I don't know. Like I could kind of see them or people thinking that this is an issue in Chrome actually, and less about an issue in like AWS SageMaker. But
I mean, the
like I don't know. It's just
mitigation
hard.
is checking origin, and that's
Yeah,
something that so that's AWS side checking the origin, and that is just a good thing that it's a best practice that you should be doing in general, is not accepting requests from random origins.
yeah.
Um, so
But
I
as far
sorry,
as I
go ahead.
know, that kind of mitigates a later stage of the attack because I believe what they're talking about there was the WebSocket for
Yes.
like opening a terminal to the victim's instance. Technically speaking, you can still set that like XSRF cookie, and there might be a different way that you could like abuse that to get access. Um, so like it is kind of a fix, but it's again one of those issues that's not like super simple fix. It's kind of relying on multiple things being broken. It's relying like this attack specifically is relying on the no origin checking on the WebSocket. It's also relying on the same site kind of bypass using Chrome. Um, but there's not like a hard fix for this, right? Because it's just kind of one of those things you have to deal with if you allow code to run on a subdomain that other things are running on. So
Yeah,
yeah,
I mean and it is kind of a great issue because of that, or a nice chain because of that, because it is chaining a few different things or a couple different things here. In terms of fixing it, yeah, like the origin checking, you do get origins on like any of your post requests and refers. So like you can check it through that to not allow cross-site access. I'm not familiar enough with the expected API and if that would be expected behavior, but checking that is just another way of going about it.
yeah. I guess
It's
another thing to mention there too is like that like same site bypass wouldn't work if they explicitly set the like same site attribute. So that's another thing they could do actually.
And I guess I should also shout out that this is something called a double submit cookie, where you have the cookie submitted as a header and then the actual check in the application, make sure that the cookie matches when you send it in the request. Um, it's not the most ideal solution to cross-site request forgery. More ideal would be that with every request, you actually generate a unique token. Realistically, though, this gets you most of the way there, but this is one of those places where had they been generating a new token for every request, and like every time you saw the form, it would have a new token, then this probably wouldn't have worked out. But the fact that they're kind of doing these double submit tokens is kind of where you're running into this issue.
Yeah. Yeah, so I mean, yeah, just a bunch of different things that led to this attack. And yeah, I mean, it seems like cloud is the like new hotness, I guess, for looking for these types of weird issues and like the code flow or like the authentication flow.
Multi-tenant anything has always had issues where it comes to like cross-tenant stuff. So I mean, cloud is just making that a lot more popular.
Yeah. Yeah, it's a difficult problem. All right, so up next we have a CSS injection in Glassdoor. Very trivial issue. Essentially, it's possible to pass a CSS key value pair in the API error page. Not exactly sure why. Seems like a weird thing to have, maybe like a debug feature left over or something. But yeah, you can literally just pass in like a CSS link in the parameter, and there's no like CSP or anything that seems to be in play here. And as such, you can load any arbitrary CSS file into the page. So the vulnerability is really straightforward. What makes this a little bit interesting is the fact that it is a CSS injection and not your typical XSS. That is a bit of a weird scenario that at least personally I haven't seen too often. And what may be surprising to come out of there is the idea of like exfiltrating data and getting code exec purely through CSS. I think we might have covered a topic that touched on this before, like a portswigger topic, but I don't have
So
a. I didn't
we
check
have
notes.
we've covered CSS injection, I think maybe once before. Honestly, this is one of those kind of weird scenarios to be in. But that's why I want to call it out. It was only $100 bounty. They didn't see us too much. But with CSS, you can exfil data, getting code execution. I think that's like only Internet Explorer, like old Internet Explorer, I think has like exec or something that you can call in CSS. But
Yeah,
CSS
it's the
exfil,
expression function.
yeah, like actually pulling out data though with CSS, like you can read the page and change some of the CSS to cause web requests and actually exfiltrate data based on what the CSS in there. So like you can get some sensitive information that way. Even on an error page, it might be including like an attribute somewhere that includes like a CSRF token that you can exfil. Because you can do queries based off things like that. And interestingly, actually, and especially since you just mentioned Portswigger, just today Portswigger put out a attack against uBlock Origin having a CSS injection issue, where they can exfil data from your pages against uBlock Origin, or maybe not your pages. I didn't finish reading it, but they talked about that just today. We'll probably be covering that next week.
That's
Since
spooky.
that did just come today. And I guess I'll do this a little bit early, but we actually have one shout out also, which was this data exfiltration through CSS. And in this case, it's using a SVG font, and they refer to another technique for it also. But yeah, like you can do a lot with CSS exfil. Like it is a cool attack that you're not often in this scenario to do, but when you are, like the entire page contents are potentially leakable. Um, Honestly, I've seen it twice in the wild, but I've seen it a ton on CTFs. It was kind of popular a few years back, I think, in CTFs.
Not just the page contents either. For the exfil for CSS, the other and attack
attributes and
they mentioned
everything
in the hacker
else.
one. Also, the like any URL data, like if there's any sensitive data in the URL, you could end
True.
up capturing that through like doing a style sheet import and monitoring the refer header. That's the last point that the researcher mentions in the report. But yeah, I mean, exfilling through CSS, like someone said in chat, IAPR, it's pretty wild, and it's cool to see. This one got paid out a $100 bounty, and it was in Glassdoor. So I think we've covered maybe one or two Glassdoor issues before, and they weren't super high paying, so that's not a big surprise. But yeah, our bounty amount for this week is pretty low. I think it's literally just this one, which is $100.
Yeah, I was kind of looking for something with a bounty this week, but I mean there were some things, it's just not a lot that was that interesting. Like straightforward SQL injection of course gets paid, but who wants to hear about putting another single quote into a search bar?
Not really that interesting to cover. Yeah.
Yeah.
All right.
There
So
are some other interesting issues. Sorry, I kind of cut you off.
yeah, no worries. So up next we have Symfony. Symfony had a web cache poisoning issue in 5.2 to 5.3.12. Z, I'll let you take this one away because I know you're a bit more familiar with like web cache poisoning.
Yeah, and I mean, this one just comes down to the fact Symfony would have kind of a set of trusted headers. So you can tell, like, hey, it's okay to trust these headers when you're, making decisions about whatever. So you can imagine things being like, X-Forwarded 4 would be an example of trusted header. And something that they added support for is this X-Forwarded-Prefix header. They recently added support for that, I believe in 5.2. And what that is, it's basically like when you have a reverse proxy, occasionally you'll mount an application on a different path than the application itself receives. So you can tell, like, here's the prefix to the application that was dropped by the reverse proxy. So that's what it's sending in. So it'd be used for some like routing information. The problem is that even if the X-Forwarded-Prefix path wasn't accepted as a trusted header, later inside the application during like the sub request processing stuff, it would handle that header. It could access that header and make decisions based off of it, which is where the issue then comes in. If you have this untrusted header, you can send that along. The application will route based off it, but if the caching server isn't aware of it and it's not trusted, so you wouldn't expect it to be caching based off of it, you could have a different cache response get saved over what the actual application should have been serving for that request. And if there were like an XSS or anything there, you can actually do something with that. It's going to depend on the application, Symfony being more of a framework that you can use rather than a full application on its own. It's hard to say what that would look like in practice, but it is kind of there as a potential issue that you could run into. But it would depend on that end application actually having something useful to poison the cache with.
That said, the fact that it is in a framework makes it very interesting for like how many potential targets this could end up affecting. So yeah, the impact there is definitely worth considering. And it's good that you pointed it out that it's a framework there.
Yeah, and Symfony is reasonably popular. I mean, it's not WordPress, but it's still up there.
I do want to say, like, this seems like an issue that I don't really know how it happens because they kind of have the allow list already set up, from what I read, and like you would think that you would be able to, like, how is it possible that there was a header that is allowed through even if it wasn't in the allow list? Like, it just seems like I can't really rationalize how that would happen in my head.
I mean, when you're
But
adding support for the header, you might just be going through, well, where needs to access this header and making direct access through it rather than going through. I don't know how the trusted headers implemented in Symfony. But I could imagine just making some direct requests using this header specifically rather than accessing it through the expected API,
through the
essentially.
controlled channels, yeah.
Yeah.
That's the only way that it really makes sense. But yeah, like as you can imagine, the fix there was they just don't forward the header anymore when it's not trusted. If it was kind of what we were speculating the issue is, they probably just changed the code to use the proper functions in place that do the checks against the allow list and stuff. So yeah, I mean, little bit weird with how it happened, but pretty impactful vulnerability. Although it wasn't in too many versions, like it was patched within like between 5.2.0 and 5.3.12. But
I don't
yeah,
know
I
what the
mean,
time frame is on that though.
yeah, that's true. All right, so up next we have a blog post from Varanus on bypassing multi-factor authentication in Box, which is a cloud content management platform. Support for time-based one-time password apps like Google Auth, Authy, and the like are pretty recent. They were introduced in January of this year. And the post here is based on an authentication issue in the MFA unenrollment endpoint, which is intended for people to be able to disable MFA if needed. Um, it turned out that that endpoint just didn't require the user to use MFA to disable it. It just required the username and password. So an attacker would at least need to know the credentials of the account to take advantage of this, unlike some of the previous attacks we've seen, where you might just need the account ID. But this kind of bypasses the entire point of MFA, so it's definitely worth bringing up and worth acknowledging. So
Yeah, just slightly impactful. Like you said, I mean, you do need to know the creds. It's a big ask, but the point of MFA is the fact that you do need to also know the MFA token. It's also one of those issues that acts as a bit of a reminder regarding those partial authentication states. It's depending on how it gets implemented, it can be hard to actually get those right and consider them everywhere in the application, where a user is partially authenticated. They logged in, they have the correct credentials, they have a session associated with them, but they haven't actually gone through the entire flow of doing that MFA access yet. So just being partially authenticated and then looking at other places that you can hit is just, a good thing to check for on applications that have any sort of partial authentication. Um, it's not the most common scenario to be in, so I think it's also just something that gets forgotten. But I mean, we've seen similar things happen before. I feel like we had a Twitter issue that wasn't this bad, but where it was like during part of a login process or something. I don't know. I can't remember the issue now, but
I vaguely remember that, but yeah, I don't remember specifics, unfortunately.
I mean, it's something that exists because that particular kind of in the middle state is just tricky to get right at times.
Kind of along those lines, one of the things that like Varanus points out towards the conclusions here that I thought I'd call out is they say although nobody is immune to bugs and vulnerabilities, to minimize the likelihood of introducing an authentication flaw into your application, it's highly recommended to delegate your MFA implementation to a provider. And yeah, I mean, I think that's some pretty good advice. It's it's just really hard to implement authentication flow, especially when you're factoring in like MFA and these extended features. Um, it's really hard to do it correctly. So that advice of like don't reinvent the wheel and just use a provider that specializes in that, like I wanted to call that out because that's a good thing to bring up
It's
there.
it's always a good thing to consider. I mean, using a provider means extra money, extra complexity in terms of doing the integration. Single point of failure, somebody finds a bypass that affects all of Authy, for example, then you're included in that. Of course, that's the downside. We talked before about like centralizing security, and it's kind of the same trade-off there. You're generally going to be more secure, but when there is an issue, it's also more serious in theory. Obviously, you can have less serious issues, but I mean, it's definitely something to consider because I mean, there's just a lot you need to be thinking about. It's the same deal with crypto, not rolling your own crypto. Um, Consider delegating that to someone, someplace that knows it well. In case of crypto, it's the good libraries for that, but Yeah, I mean it's something important to consider is where you can offload it. At the same time, a ton of companies kind of have that whole not created here syndrome and like a fear or phobia, and try and avoid actually having anything that is not created in house because they can't trust anybody else, which I think is just a bad take.
Seems to
How
be a very common uh, fear for companies to have.
yeah,
Um,
it is, unfortunately.
Not sure why.
I mean, a
Yeah.
company that focuses on authentication is probably going to be aware of more issues than you are and do a better than you are. Like it's literally their job is to get auth right.
IHBR in chat said my favorite MFA issue that I ran into a lot is like 5-digit numeric MFA token and no brute force protection on the endpoint. So yeah, we've covered a few issues like that before on the podcast actually, where they had like it the flow worked, like they had the MFA set up for changing passwords and stuff like that, but it just wasn't protected against brute force. There's no rate limiting or anything. Yeah, there's just a lot of things that you have to consider when you're dealing with it. So it's not surprising to see that it's so often gotten wrong when they're not using like a specialized service for that. So yeah. But then we can get into our last topic here, which is a blog post from Google's security blog on Kubernetes and a talk to during the creation of subpath bind mounts inside of a container. The post goes into some background on what exactly the subpath storage system is in Kubernetes and how it works and how the Vault ties into that. The bit you need to understand there is Kubernetes features a volume subpath feature with the goal of enabling sharing of a volume between multiple containers in a particular pod. It's kind of similar. Like you'll see this in some other areas as well. I don't think that's really exclusive to Kubernetes, but um, they point out it's historically been a bit of a bug farm and a great target for vuln research because kubelets operate with privileges on the host, and they need to be really careful when dealing with user-owned subpaths because these subpaths are not controlled by the system; they're controlled by the user. Um, they point to an example case of a previous vuln based on this, where, for example, a malicious workload could get in a init container to create a symlink to any location on the host. Then another container later on could end up trying to mount that same volume. It would follow that symlink, and then it would follow it to the host file system instead of the containers. So, for example, they'll go to like the hosts at C directory instead of the containers. The fix for that issue was to resolve the path and validate that it points like inside of the volume. And to ensure there was no time of check, time of use issue there, they tried to ensure the host path isn't changeable by the user between validation and when the container runtime uses it. But Google ended up discovering another route to exploit this, using another talk-to attack to bypass validation of the path against the host directory. They still did a symlink attack, like the one that I mentioned earlier, but they continuously swap the symlink with a directory using the rename exchange option. And by doing that and replacing it with a directory, it's able to get past that validation, but because it's not actually changing the path, um, the other checks that were put in place aren't really useful here. So that's why there's still this time of check, time of use, where if you can get the race lined up well, the kubelet ends up seeing the path as a directory when it tries to do validation. It thinks everything is fine, it's just a normal directory, but then the mount utility might end up seeing that path as the symlink and end up following it. So yeah, I mean, this was probably like the most fun issue that I read about this week. Uh, it's just
I mean,
symlinks
it's
are hard,
talk
man.
to. I mean,
Talk tos
I
are the
bring them
best.
up all the
Yeah.
time. I love these sorts of issues because they're not intuitive. I mean, you can kind of start thinking about them somewhat intuitively, but they're not always straightforward. You have, at least for myself, I always have to kind of remind myself that it's possible things keep changing out from under me. Like you don't just, I don't know. I just like
It's
them.
tough to
They're
write
fun.
code with like the talk to in mind. Yeah.
Yeah, in this case, they basically just shifted where that talk to happens to the later stage because it ended up being mount itself that would follow the one sim link through. So mount sees it differently, which is a little bit later than the other one, or than the original one. But yeah, I mean, I really like this phone, and I think it's a great one even to end the show with. It's fun, and I just love these talk tos. I say that like every time we cover these sorts of talk tos.
Last thing I'll mention is for anyone who might be wondering why like Google put out this blog post, it's because I believe the GKE, which is like Google's own cloud platform, uses Kubernetes for like what they do. So
Well,
it's
Kubernetes
kind of
is from Google. Like
yeah.
they created Kubernetes itself,
So
I think.
that's yes, yeah. Actually, you're right. For some reason, I was thinking Kubernetes was done by a third party, but I think you're right. It is actually from Google. So yeah, I mean, makes sense that Google would be putting out a blog post like that. I mean, they've always kind of been opened, like open source or open nature when it comes to talking about security issues and like their own products, or even in products that their services depend on. So yeah, that kind of explains why they have blog posts here. They do have some nice diagrams as well to follow if you're more interested in like the specifics and like the control flow of what's happening. So I did want to call that out. You can check out that diagram if you want to later on. But
Yeah, good
yeah,
post and very readable, just in general. It
yeah,
flows
very
nicely.
accessible for sure.
Yeah.
All right, so yeah, we can move into our shout outs of the show now. Z, I know you have two of them, so I'll let you take those away and then we'll move to wrapping it up.
Yeah, two shout outs, one of which I've already spoiled for everybody. First one here, though, Hakluke, creating the perfect bug bounty automation. I just thought it was a kind of interesting take on automating a lot of the bug bounty process, especially if you're getting started. Might be worth taking a look at somebody who's essentially started off just by, writing some shell scripts to automate a few things, rewrote it several times, getting towards something much better, scales better. Just a good read if that's what you're into. No real vulnerabilities brought up here, but still some things to at least consider. And the second shout out is the same one from earlier, data exfiltration through CSS and the SVG font. Basically, have a CSS injection using an SVG font. I think this one was specific to Safari. Uh, just another technique though that you can at least explore if you find yourself in that scenario or in
Sorry, just
that
to jump
CSS scenario. Sorry, go ahead.
Just to jump back a little bit on that last topic, it's what we were talking about with Kubernetes. So the reason I was confused was Google was the original author of Kubernetes, but the developer that's actively maintaining it is the Cloud Native Computing Foundation. So it seems like there was kind of a handoff there. So yeah, that was just the source of my confusion on that last topic, just for anyone who
Okay.
might be wondering. Um, but yeah, sorry, did you have one more shout out or did you
Nope,
cover them
that was the
both?
last
I think
shout
you
out.
all right, cool. So yeah, thank you to everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. We'll be back tomorrow for the binary episode at 7 p.m. Eastern, 4 p.m. Pacific, which is where we'll also cover the Spot the Vuln solution that was briefly shown in the pre-stream today because we accidentally forgot to put it up right away. But that's also in the Discord as well for those who might have missed it and want to check it out. Again, before we go, we will be going on our winter break after our bounty and binary episodes next week, and we'll be returning on January 10th and 11th. Other than that, though, we'll see you tomorrow when we return for our binary podcast. Take care.